Here we are, Alejandro Rubio, Pedro Rivera, and Antonio Mosqueda, and here we are to present Zigbee, Control Your World. And what is Zigbee? Zigbee is a wireless technology, a high-level communication protocol based on the IEEE 802 standard. It was created for small personal area networks built from low-power digital radios. Its applications require low data rate, long battery life, and secure networking. Zigbee emerged because Wi-Fi and Bluetooth suck at efficiency, especially with energy, and they lack mesh capabilities. So in 2003, the IEEE released the 802.15.4 standard for low-range wide personal area networks. So in 2004, the first Zigbee specification was revealed. And then in 2007, the last Zigbee specification has been revealed. Zigbee works in 3 different bands. In the ISM 2.4 GHz global band at 250 kilobytes per second, the 868 MHz European band at 20 kilobytes per second, and the third is the 915 MHz North American band at 40 kilobytes per second. Zigbee works in 2 bandwidths. For the 2 GHz band, it works at 5 MHz, and for the 915 and the 868 MHz, it has a bandwidth of 2 MHz. So, the modulation. Zigbee works in 2 modulation schemes. The first one is with an offset quadrature phase shift keying for the 2.4 GHz band, and for the 868 and the 915 MHz band works with binary phase shift keying. The receiver architecture of the Zigbee has many important parts. The first part is the low noise amplifier. The second part is the quadrature down converter, which works pretty much like a frequency detector. The third stage is an analog filter, which can be a band pass or a low pass filter. The next stage is an analog and 2 analog to digital converters depending on the frequency. And the last stage is a digital stage which includes gain control, image suppression, channel filtering, demodulation, and synchronization.
And now, if you like, let's take a look at the transmitter architecture. And this first transmitter architecture is basically the same as the first receiver architecture we saw, but in this transmitter we are going backwards. First, we have a digital part which is converted into a digital signal. Then it goes through filtering and smoothing, which conditionate the signal, and then it goes through a quadrature up converter, which is this part, to go to the power amplifier that takes out the signal. And the second transmitter architecture, it's a little bit more difficult, but it takes less power. We have a phase lock loop, which is over here, and we have a PCO. And what does this do? By varying the division, the radio in the phase lock loop and the frequency in the PCO, the modulation is achieved. It produces some MSK modulation and is more power efficient. Then we have this structure, which is a transceiver. And what is a transceiver? A transceiver is a device in charge of transmit or receive the signal. It's basically a conjunction of the 2 transceiver and receiver architecture we saw, but we have a digital system that can determine if we want to receive or transmit. In this case, we have a integrated frequency synthesizer, so we don't need a DCO or a loop filter.
About the security issues, Zigbee features 128-bit encryption and access control lists, so security is pretty strong. But there are several downsides. There is physical hacking, which means that any person could, with physical access to the device, could create serial communication with the microcontroller and steal data such as keys, or it can make it go wrong. The next type of security vulnerability are key attacks, which we found two methods. One is a fake node attack, which is executed by using a fake node, which is a device, an intruder device. And the other one is with a commercially available device called Killer Bee. It's basically the same. The other kind of attack is called replay and injection. It is widely used in Wi-Fi networks to get WPA or WEP keys. And the last kind of attack for Zigbee is the wake-on power attack. It takes advantage of vulnerability. It sends commands to the Zigbee, so it can't go to the sleep mode or idle, and it stays wake on for a lot of time until the power drains and the node becomes unavailable.
Now, talking about the network architecture, we have three types of devices. The first one is the coordinator. The coordinator is this black spot in the middle of the architecture, and this coordinator, it's like the one that commands everything. It's most capable, and there's only one per network. Then we have the router, which is also called a full function device. And it can either receive or transmit information between two other routers. And at the end, we have the end devices. And they are light and simple, and they can relay on data, so they can transmit, just receive. Next, we have these architectures, which are three topologies. We have the first one that is a star. The star architecture is based on the coordinator. So the coordinator determines where those information goes. So it's like really dependent. We have the second one, which is a mesh over here. And the mesh, we don't rely on the coordinator all the time. So we can send information through the full function devices, either here over there, and then go to the end devices. And the last one is a cluster tree, which is a combination between star and mesh. We can have our coordinator over here, and we can go through the coordinator backwards, forwards, and then go through the end devices through a different pathway.
There are many applications for Zigbee that range from the industrial monitoring and control to home automation, to sensor networks, to gaming, and medical and automotive solutions. They all belong to the wireless personal area network technologies.
If you like, I like to remind you that our project, which we deployed in the Expo Electronica, can be used in Zigbee. So we have this example of the control of the home automation.
Now, the IEEE 802.15.4 standard. This standard specifies the physical and media access control layers of the Zigbee protocol. The rest of the layers are specified by Zigbee wireless technology, which are network, security, and application layers. About noise and interference. Zigbee features low noise vulnerability because of the digital communication. Digital communication lets us have a big gap between symbols. Image interference does not affect the system if zero intermediate frequencies are used in the receiver. So as we saw, Zigbee has no big issues with the interference. About the antennas, there are two types of antennas used: printed monopole and microstrip patch antennas, which are etched directly on the PCBs. These are very compact, and they are reliable for low distance communication. And the other kind of antenna are the sleeve antennas, which pop out of the PCBs, and let us have better transmissions. About regulatory issues, we didn't find a lot of issues in terms of regulation for Zigbee because no license bands are used. So the frequencies used don't require a license for the users, and it has fair. The Zigbee protocol is fair in terms of coexistence. IEEE standards require that you specify your coexistence agreements with other bands and frequencies. So it does well on regulations. We were asked to think of a cool application, and apart from what our teammate Alex said, we thought that we could use Zigbee devices on their cars or on parking spots in parking lots, so that when a user enters a parking lot, he can see where there is an available parking spot. These nodes under each slot communicate to each other until they reach a central computer, which displays the data to the users entering the parking lot. And that will be all. If you have any questions,
please contact us. You have our emails and all the stuff that you need to regarding all your doubts. So,
but our personal recommendation would be for you to Google it out. Thank you.
Thank you very much.